Okay, inverse trigonometric function. It is our topic. Inverse trigonometric function. To understand inverse trigonometric function, first of all, we study function and its inverse. Function and its inverse. So I am giving a very easy example to understand what is a function and what is its inverse. So to understand a function, let's take an example. Suppose we have a function 2x plus 3. Suppose this is a function, and you know, in function we have always a two set, r to r, and I can denote r to r like this. This is a set of domain wherefrom we are giving value to this function. It means in this function x will take value from this set, and finally the value of the function will come into this set. This is called domain of the function. And this is called co-domain of the function. Suppose I am taking some values from this set domain, and I will find out the value of the function on those particular values. Suppose x is equal to 1. So if I am putting x is equal to 1, so I will get 2 into 1 plus 3. It means the value of function at 1 is equal to 5. 2, 1 plus 3, 5. Similarly, if I am taking, suppose x is equal to 2, then I will put x, in place of x I will put 2, then 2 2 is 4 plus 3, 7. So f2 is equal to 7. So in this diagram, I can represent the value of x like 1 and 2, and the value of images 5 and 7. So you can understand the image of 1 is 5 and the image of 2 is 7. So 1 and 2 are also called input, and 5 and 7 are also called output. So in this function, when I am giving some input like 1 and 2, then I am getting some output like 5 and 7. So the function is working like a machine in which I am giving some input and equally I am getting some output. So as I told you, this function is working like a machine. In this function, suppose I have given an input 1, so the output was 5. So 1 was the input and 5 was the output. Similarly, if I am taking x is equal to 2, so I am getting output as 7. It means image of 2 is 7. So this is the way from we are getting output from the input. So now we will study what is the inverse of a function. This was the example of function. It is important to note that all permissible values of inputs will make a set of domain. These set 1, 2, and what possible value I can take to this function will make a set which is called domain. Similarly, the set of all outputs will make a set which is called range. So these sets will create domain, and this set will create range. There should be no confusion between range and codomain. Range is the set of all output and codomain is the set of range and codomain. Okay, so these set 1, 2 is called domain and this is called range. So I was telling there should be no confusion between range and codomain. Actually, range is the subset of codomain. It means range can be put in the set of codomain. Now we will study what is the inverse of the function. So inverse of the function is a mechanism, is a technique where we can understand is that if I was the output, what was the input? It will go in the reverse direction. So F inverse means the reverse mapping. Okay, so how will we find the inverse of this function? So whenever we are finding the inverse of a function, first of all, in place of fx, we have to put y. So y is equal to 2x plus 3. So in this expression, y is a function of x, but we have to change the scene. We have to create x as a function of y. So for this we will bring 3 on the left hand side. So we will have 2x, and finally to find x, we can write like this, y minus 3 upon 2. So now since y is equal to fx, so I can write x is equal to f inverse y. So in place of x, I can write f inverse y is equal to y minus 3 upon 2. So this is the rule for the reverse mapping. This is the rule for the reverse mapping. How I can say this is the rule for the reverse mapping? This is the inverse function. So in the function we study that if 1 is the input, so 5 is the output. But if I am putting y is equal to 5, so let's check. F inverse 5 minus 3 upon 2, which is obviously 1. It means 5 is the corresponding input is 1. Suppose if we have to find F inverse 7, so we will put 7 minus 3 upon 2, which is obviously 2. So inverse, so function is the straightforward input and output mechanism, and inverse function is the reverse process where output can lead to the input. This is called function and inverse function. Now what is 1, 1 and onto function? So to understand 1, 1 and onto function, 1, 1 and onto function, we have to understand, and 1, 1 and onto also called bijective function. So what is 1, 1 and onto? So 1, 1 and onto function, in 1, 1 and onto function, one function can have only one image. One element will have a unique output, and you can say that two inputs cannot lead to the one output. It means if two elements are having same image, it will not be 1, 1. Okay, and no element of codomain is like that which is not having a pre-image. It means codomain must equal to range of the function. So this is called 1, 1 and onto function. 1, 1 and onto function, which is also called bijective function, which is also called bijective function. So 1, 1 and onto function, and you know there is a horizontal line test. Horizontal line test to check 1 1. To check 1 1 dash of the function, there is a horizontal line test. So what is this test is? Suppose I have a graph of any function and I am drawing an horizontal line. If the horizontal line is intersecting curve more than 1 point, then this function will not be 1 1. This is called horizontal line test. So this was the introduction of function and inverse function. Now we are coming to the point inverse trigonometric function. So to understand inverse trigonometric function, let us consider a function fx is equal to sin x. This is a function, sine function, and you know the graph of the sine function is, so we can draw the graph of sine function like this and so on, and on the left hand side also. And you know function at x is equal to 0 0, f pi by 2, the value of sine pi by 2 is 1, then pi 0, then 3 pi by 2, this is minus 1, then 2 pi again 0, then 5 pi by 2 is also 1. So you see that this function is neither 1 1 and nor onto. So this function is neither 1 1 and nor onto. It means we cannot find the inverse of this function, because to get inverse of a function we must have a 1 1 and onto function, that is bijective function. Invertible functions are bijective function. So only bijective function can be inverse. So we will modify domain and range of this function. So how can we modify? Suppose if I am taking, this is minus pi by 2, minus pi by 2 to pi by 2, only this part of the domain. If I am taking only this part of the domain, suppose this point is minus pi by 2 and this point is pi by 2. Similarly, I am modifying codomain, so I am taking minus 1 to 1, minus 1 to 1. So I am dealing with this branch only of this curve. I am taking this arc only. This is called principal arc. This arc. So this is called principal arc. So domain, now new domain is minus pi by 2 to pi by 2, and now our codomain is minus 1 to 1. This is the range of the sine function. Minus 1 to 1 is the range of the sine function, and this is the domain of the function. So now this function fx is equal to sin x is 1 1 and onto. Earlier it was neither 1 1 nor onto, but we have modified its domain and codomain. Now this function is 1 1 and onto, hence it is bijective, so it is invertible. Now it is invertible. So what was the inverse function? F inverse will be from this domain minus 1 1 to minus pi by 2 and pi by 2. So this is called inverse, and we denote it sin inverse x. Now this function is sin inverse x. So this was the introduction of inverse trigonometric function. In next lecture we will study some formula related to the inverse trigonometric function. Thank you very much.